Hi, Mike Matchett with Small World Big Data, and we are here talking about how to really speed up databases. We've got lots of data these days, and there's lots of people doing different things in software and hardware and in sort of a hyper-converged way to try to optimize our data pipelines and data paths, but it's not clear where the world's going, given that data just keeps exploding. And is this really a software problem, a hardware problem, a combination problem? Let's find out. I've got Elad Sity here with NeuroBlade. Welcome, Elad.
Hey, hey, Mike.
All right, so tell me a little bit about NeuroBlade and how you got started into NeuroBlade. What caused you to take a look at this particular problem?
Sure. So I think the story starts like many other stories. We were playing around with something which was actually stock trading. Lots of tick data. You want to try and do some neat, cool things on it, like putting it in a database, running it through a neural network, and playing with many things. And like any good real-time engineer, we kind of lost focus on the target at hand, which was stock trading, and got into dealing with why is this running slow. And what can we do to make it run fast? And one of the things that we understood is that CPUs are not built for these kind of workloads. Also, not GPUs. GPUs are built for the use case when you have when you want to run vast amounts of computation. But what happens when you want to run through vast amounts of data? So we said we are going to build the next platform to handle with big data tasks. And big data is, of course, today a lot of data analytics. How do you get more insights and faster from the data that you have today? How can it make your organization better and so on? But we stick to the portion of helping you get better insights by accelerating the speed of your queries.
All right. So before we go into exactly what you do, let's just stop for a moment and look deeper into that statement you made about GPUs and CPUs. So CPUs, general compute, they're getting faster according to Moore's law and so on. We can have multiple cores. But when processing data, people tend to think of the GPU today for machine learning and for tasks that require a lot of, basically floating point math, where we're doing a lot of calculations very fast. And a lot of optimizations in the last couple of years, and a lot of companies are focusing on the GPU and how do we make GPUs available, NVIDIA and so on. So maybe tell us just a little bit more about why the GPU doesn't satisfy the needs to process more data in a database kind of way.
Mm-hmm. Sure. So if you look at the workload and the operands that you use in a database, but mostly I'd say it's how the data flows through the system. If you think of a GPU, you grab some data, run a lot of computations on that. But if you look at all those data analytics workload, what you'll see is that you have, again, vast amounts of data. And on each portion of the data, you do some computations. Think of something like a filter, okay? I just touch the data and it moves on. So it's really more of a data flow kind of architecture where you process along the way. And this is a much better fit for this kind of workloads where you actually just want to open up more bandwidth, more sources of data, and not necessarily, again, just grab a portion of it and run a lot of computations on that.
So kind of a difference between like a machine learning training cycles where we're really looking at stuff and, big data where we might have even had like MapR or something where we've partitioned the data out widely just so we can get that parallel bandwidth flowing through here. You guys are approaching this slightly differently than, say, Hadoop or a partitioning of the data. Tell us what NeuroBlade then is. Where did you go if you couldn't use CPUs and GPUs to do this? What did you do?
Yeah, so it's interesting because again, as I mentioned, originally we are real-time engineers and start looking at hey, here's one bottleneck. What if I solve this bottleneck? Oh, there's another one here. There's another one here. There's one between the memory and the CPU. There's one between the storage and the CPU. There's one between the storage and the networking and the CPU. And all of that is orchestrated and deeply connected into the software. And you could see today there's a lot of innovation to speed up data analytics in every fragment of the system. So starting from the software, companies doing pure software solutions, a lot of indexing and smart caches and whatnot. There's a lot of innovation on the compute side. Obviously, Intel, AMD, NVIDIA are all deeply invested into building more accelerators into their platforms to speed up these workloads. On the networking side, you see today, going from TCP offloading to smart NICs and DPUs and so on. On the storage side, faster storage, smarter storage, and so on. But when you look at all these portions that people are trying to speed up, you'll see that you'll gain between 0 to 30% per gain. And this is because even if, let's take computational storage, for example, the disk may give you in a certain kernel 100x performance. But when you run that in an entire system, and data analytics is really a system problem because you need to run the data through all those portions that I mentioned, you see that you are getting nothing or getting 10% or getting 30% at best. And what we did at NeuroBlade is look at all the stack, software, hardware, memories, storage, networking, everything has to be connected. Everything has to be optimized for this specific use case of data analytics. And we look at this whole thing in a much more holistic way, trying to really build out all the parts together. And this is how you get to the, you switch from gaining percentages to gaining X's, 10x, 100x, and even more in the future.
All right. So instead of tackling just one part of the problem in an entire stack of technology, you looked at it and said, when I run a database query, I'm using that full stack, and I have to optimize the entire stack together as a complete unit. So what are some of the things you've done inside that stack to make it faster?
So I think one of the things is probably hard for people to do now is imagine what we actually do. So we built an entire appliance for the data center. We call it HEQS, Hardware Enhanced Query System. And this thing really includes inside it the networking, a processing that we have developed on our own, the storage, some NVMe memory, and it's a complete system. And everything is orchestrated by lots and lots of software. So we really try to stack up everything. And I want to clarify one thing. We don't want to compete with the data warehousing companies or the data lake companies. We actually want to help those companies speed up their products. Okay? So if you are one of these companies and you use NeuroBlade, your database, your solution becomes faster.
All right. So this is something that can layer on top of existing things. It's not like throw away your data lake investment and put it all in here. This is something you can say, oh, look, I've got some need for real-time database queries or near real-time, whatever the speed you're going to get, 100x, on that massive amount of data. And once you do that, and you start thinking, oh, there are a lot of use cases that people could use more well, I would say real time again, but 100x speed up in database performance. Things like doing behavioral analysis in real time, things like that. What do you see? What do you see people doing with this? And you mentioned finance before. Are there other use cases that they're becoming pretty popular?
So real time and finance are, I'd say, the easy suspects, the usual suspects.
Yeah.
But you can see many interesting things like healthcare use cases, medical use cases. We have a very interesting use case in semiconductor manufacturing. You see that in all these cases, a customer sometimes waits. I'm quoting one of the customers. Okay, I have to wait 7 days to know what happened today. So by definition, I don't know what happened today. And I'm optimizing my manufacturing floor according to these results. So if you can shorten those 7 days to a few hours, every day you get more production, better quality. If we are looking at insurance, okay, you have less insurance claims or less false claims and so on. So this all translates to real revenue eventually, speeding up those queries. And real time is just one aspect. That's what I'm saying. So.
All right. And so, just sort of say what we're really doing here is focusing on accelerating the data movement, getting the query comes through the NeuroBlade architecture, whatever it is, and it leverages the underlying storage engines, whatever they might be, and integrates tightly with those, so some tight integration there. Does this support parallel queries and multiple users as well? Is this an architecture that's kind of single-threaded?
So it's a great question. So initially when we just started, main focus is speed up, and then you start talking to customers, and the first customer is saying, is a cloud vendor, and he's saying, do you support multiple queries at the same time? Oh, do you support multiple users at the same time? Do you support multiple organizations at the same time? And now you also need to encrypt differently between customers so they can't feel each other. So yes and yes and yes. Eventually, it's a cloud native product.
Okay.
That's how we treat it. Of course, you need to support everything.
So a big cloud provider might have data lake services already, but they could bring in this NeuroBlade architecture to offer it as a cloud service, accelerated query service to their clients, and it would support their multi-tenancy and all the other things going on. That's pretty cool. Tell me, you mentioned HEQS before. That's HEQS if you're trying to follow along here. You mentioned that this is a full stack thing, but I know you've got hardware in here, and I think it's kind of interesting from the software to the hardware. You've got what do you call some of the hardware things that you guys? They're not GPUs. What are you calling those things?
They are called HEQS processors.
HEQS processors. Okay, which is the name of the system. All right, so. Some interesting stuff going on there. If someone wants to know a little bit more, Elad, about NeuroBlade and maybe how they could get real-time query performance, or again, I probably shouldn't use that word, but 100x query performance out of their existing data lake or database or massive amounts of data. Obviously, you got a website. Anything in particular you'd have them take a look at?
Either neuroblade.com or just LinkedIn to me, and we'll take it from there.
We'll take it there. All right. There's a personal offer. I love that. Thank you so much for being here. I think there's a bright future here. Everyone's got tons of data. There's more data coming. We're gonna have more. We're gonna have more data tomorrow.
More data as we speak.
As we speak, the data's not slowing down. So good market to be in. Thank you so much for being here today.
Thanks a lot for your time.
All right. Take care.